Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at dynamic network address translation. We'll be discussing dynamic network address translation, configuring dynamic NAT, analyzing dynamic NAT from the inside to the outside and also from the outside to the inside, and then finally we're going to verify that dynamic network address translation. This episode is part of my series on enterprise networking, security, and automation. I'm Kevin here at KevTechify. Let's get this adventure started. Dynamic NAT is a one-to-one translation, one inside address to one outside. What dynamic does is it automatically maps an inside local, so an inside local, to an inside global address. Now, once again, this is location and point of view. Location and point of view. And so because they're both inside, we're talking about our inside devices here. And where are we viewing it from? We're viewing it from the inside of our network, and then we're going to map it to that outside IP address. Specifically, it's going to be this IP address right here that we do a lot of the mapping to. Dynamic uses a pool of addresses. That pool of addresses could be from 1 up to 200. It's whatever you get from your internet service provider. He tells you can use. Of course, you have to pay for them, but it's a group of addresses. And that pool has a finite number of addresses in it. Now, that pool of inside global addresses, once again, they're public IP addresses that we can map to inside devices. It's available to any device on the inside of your network on a first come, first served basis. And so the first address, your first device on the inside of your address that requests to do some network address translation is going to use the first address in that pool. Then the second device on the inside of your network is going to use the second address available in the pool. And it's going to go ahead and go through and allocate all of them until all the pool addresses are used. When that next device, one more than the number of addresses in your pool, wants to get an address from that pool, it's going to have to sit there and wait. It's going to have to wait until one of those devices become available. Normally, dynamic NAT is initiated from the inside of your network going out. You have inside devices that want to connect to outside services. You have your people working on the inside of your company that need to connect to websites out there to order pieces so you can make parts, so you can make money. That's normally how dynamic NAT works. There's 3 steps to configure dynamic NAT, and then we have to apply it to the interfaces. The first step to configuring our dynamic NAT is to define a pool of addresses that's going to be used for translation. This is the IP addresses you're going to get from the ISP. Your ISP is going to route all traffic for those IP addresses to your router. And so to set up that pool, we start here from global configuration, IPNAT pool. We give it a name. Here we're going to give it NAT-pool1. We have all capital letters. The name is case sensitive, so remember that. The name is case sensitive. Reason it's all in capital letters just makes it a little easier to identify when you're looking through all your configurations. Then we have the start IP address of our pool and the ending IP address. Now, this isn't a network address and then you give it a subnet mask. This is the actual start and stop of your IP addresses in your pool. So it could be 1, 2 addresses. It could be 100 addresses. It's whatever your ISP gives you. You need to make sure when you request these IP addresses, you say you need a block of 6 IP addresses, and that'll tell them that it needs to be numerically in order. So you put your start IP address, your end IP address, then you need to specify your subnet mask here for those addresses. Once you define your pool of addresses, you need to create an access control list to identify who is permitted to use those addresses that are to be translated. So who's going to be doing that? We create just a normal standard access control list. Now, it could be standard, it could be extended. Here, we're going to create a standard access control list. So we start off access list, and then we put it as access list 1, and then we're going to permit this network. Here, we're going to permit anything on the 192.168 network to go through and do network address translation. Where you would probably use this in a corporate setting is you're working in a machine shop. You have people that work in the front office, you have people that work in the machine shop. The people in the machine shop, they shouldn't be browsing Facebook while they're working. So you're not going to allow them to have access to this network address translation. But the people in the front office, they need to use the web to do their jobs, to order stuff, to pay bills, to look up information, to contact customers. They need to have access to the internet. And so you're going to allow that group of computers, and you should have that put in their own network, that network access to the network address translation. And that's what we're setting up here, is allowing it in our network address, in our access control list. Once again, make sure you always have a permit in there, because if it doesn't match a permit statement, or it doesn't match any statement up above it, we have that implicit deny at the end. Once we have our pool defined, once we have our access list of permitting who to use our network address translation, we need to bind those two together. We need to bind the access control list with the pool of addresses. We do that using the Ipnat inside source list command. So Ipnat inside source, then we give it the access control list number. Here is the access control list number. We got that from the access list we just defined there. Then we say pool, and then we give it the name of the pool. Once again, this is case sensitive. This is that pool we just defined 2 lines earlier. And so that binds those two together. The people who are permitted to use those pool of addresses. Once we've done that, now we need to say which interface is our inside address, which is our outside for our network address translation. I'm going to go back a slide here quick. When we look here at our example, serial 001 is on the inside of our network. Serial 011 is on the outside. So serial 010 is on the inside. What we do is we go into the interface of serial 011 or serial 010. Then we say that this is Ipnat inside, sets this interface as the inside of our network address translation. And then we go into the other interface, serial 011, and we say that is the outside interface of our network address translation. If you like this episode on dynamic network address translation and you get value out of it, and of course, depending upon what platform you're using, please click that like button, give a 5-star rating, subscribe to my channel, leave a comment. Doing this supports the channel, which in turn helps me bring you more great content. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. When we look at how dynamic NAT works, we typically look at it in 2 parts. The first part is when we go from the inside to the outside, and then the second part is when we come back from the outside to the inside. Here we have the inside to outside. So one of the PCs here is initiating a connection to our web server on the outside. So we're going from the inside PC1 to the web server on the outside. It makes a request. The destination IP address is the IP address of the web server, but the source address is the IP address of the PC. So 192.168.10.10. That is our source address on this packet we are sending out to make our HTTP request. When the router gets in this packet and it looks to see, is there any private IP addresses in there? It says, oh geez, that source address has a private IP address. We need to translate that source address into a public IP address. And so it looks at the pool of IP addresses, it assigns one of those IP addresses from the pool to this conversation that's happening, and it then rewrites that source address into that public IP address. It sends it on its way. The router sends that packet on its way. Once again, the destination is still that 209 address of the web server. It sends it, routes it across the internet, makes it to the server. PC2, in the meantime, also wants to send a web request to the web server. And so it sends out a packet here with the destination address of the web server, but the source address of the 192.168.11.10. That's the IP address internally of PC2. R2 gets that in and says, gee, we can't forward a private IP address, so what we're going to do is we're going to translate that IP address. We're going to grab the next available IP address from our pool of addresses, assign it to this conversation. We're going to change that source address from a private address to one of our public IP addresses, send it on to the web server, and then that web server will get that request in. So that web server has got two requests in from two different IP addresses. If we look all the way back at the start of the conversation, PC1 made one request, PC2 made two requests. The web server got it in with two different source addresses, .226 and .227. Once the web server processes those HTTP requests, they send it back. But when they send it back, they invert the source and destination addresses. They invert them. And so that first conversation with PC1, the destination address is 209.165.200.226. That's what it received in the request. That's who it's sending it to. This address is routed to R2. And so this 209 address is routed to R2 by your ISP. When it gets it in, it looks at its network address translation table. It sees, okay, we have a conversation where the outside address is 209.165.200.126. And that's mapped to the inside local address of 192.168.10.10. So it translates that. It changes the destination address to what it needs to for the conversation to be able to deliver that to PC1. Very shortly after that first HTTP response leaves, that goes to PC1. The web server sends out an HTTP response to PC2 with a destination address of 209.165.200.227. The second address in our NAT pool, it's routable to the IP, or it's routable. The ISP routes it to our router. The router gets it in and says, oh, I have a conversation where the outside local IP address is 209.165.200.227, and that's mapped to the internal address of 192.168.11.12. Let's go ahead and change that destination address so that way I can route it to PC2 and it can get its information. And so that R2 is doing the translation there, dynamically grabbing IP addresses as needed from the pool of addresses. To verify your dynamic NAT, we can use the show IP NAT translations. Type in show IP NAT translations. It's going to give us all the static translations that have been configured and any dynamic translations that have been created by traffic. Right here is our two dynamic translations that were created when we queried the web server to get a web page. Now, you can get more information about our translations by adding the word verbose on the end. So our command would be show IP NAT translation verbose here, adding this keyword on the end. And it'll give you a lot more detailed information. One of the interesting things is how long ago was this created? This was created, this network address translation was created 2 minutes and 11 seconds ago. The timeout here is 86 million seconds, which I believe is 24 hours. And here it says this is the time left for this NAT here. Defaulting to 24 hours is the start, or is the time to have your network address translation. We can see the second translation down here, same information. We have amount of time left. When you're looking at your dynamic NAT statistics and the translations you actually have, you can time them out. The default timeout is after 24 hours, it'll be removed from the network address translation table. But if you want to, you can go ahead and you can change that. IPNAT translation timeout will allow you to set how many seconds that translation is going to stay in the table. If you want to clear out your translations manually, you can use the clear IPNAT translation and then put a star here, and it'll clear out all of your dynamic translations. If you want to clear a simple dynamic translation or clear out one entry, you can get more specific. You can say clear IPNAT translation inside, and then you can specify the global IP and local IP, and you can remove one of those network address translations. So if everybody's working just fine, but you have one problem one in there, you can go ahead and you can remove that one. We can also use the show IPNAT statistics command. When we use the show IPNAT statistics, it'll give us some information down here. We have 4 active translations, all of which are dynamic. The peak translations that occurred 31 minutes ago. We say what our inside and outside interfaces are. How many hits? Once again, a hit is a match to our address translation. A miss is there was no matches and we had to create a dynamic address translation. Then we come down here and we can look at some pool information. Down here we have access list 1 pool NAT. This is the mapping or binding of our ACL to our pool. Here's our NAT pool. It tells us what our start and end IP addresses are. Total amount of addresses is 15. How many we have allocated, and it gives us percentage. There, we can get all of that from our show IPNAT statistics. We can also look at our show running config. In our show running config, and we can filter out looking for any line that includes the word NAT. So we're going to include any line that includes the NAT. Right here we have our pool, where we set up our pool. And then we also can see that we have our binding between our access list 1, which is right here, and our pool name of NAT-pool1. It was my pleasure to provide you with this wonderful episode on dynamic network address translation. If you like this episode and got value out of it, and depending upon what platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com, and you can get all these episodes in video and podcast form. In the upper right is my playlist for my series on enterprise networking, security, and automation. In the bottom right is one of my favorite videos that I put there just for you. Thank you so much for watching this episode of my series on enterprise networking, security, and automation. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.